Hello there, everybody, and welcome to a very special impromptu live podcast I'm doing with Ravin Kumar from DeepMind. What is up, Ravin?
Not much. I'm excited to be here again with you. It's always
I'm
great being on this podcast.
Yeah, so it's always so much fun to chat, and it's just great to do things in public as well. We have so many fun conversations where I learn a bunch. So I love sharing it with the world, and just welcome everyone, and thanks for joining. So impromptu-ly, if that's a term. This is Vanishing Gradients, the data science, machine learning, and now we call it an AI podcast. The Q&A will happen in Discord, and I've put the link in the description. Jump into the podcasts channel. Any questions, we'd be excited to answer and engage with you all. We just do that so we can follow up afterwards as well and continue the conversation. If you like this type of stuff, please do hit like and subscribe and share with friends. I just a few things about Ravin. Ravin is a researcher at DeepMind for the last decade. He's focused on applied generative models. Previously built bespoke probabilistic Bayesian models for organizations like SpaceX, and more recently been working on LLMs such as Gemma and Gemini. Contributed both to products Notebook LM, and Project Mariner. We're going to chat about all these types of things today, with a focus on AI evaluation and agent evaluation for products as well. But also, I woke up this morning and saw Gemma 3. So many congrats, Ravin.
I, Gemini 3.
Oh, I'm
Gemini 3.
sorry. Yes. No.
Yes, yes.
Yeah. I was too excited. Yes, of course I knew that. But many congrats on Gemini 3.
Thank you.
So, is there anything by way of introduction that I missed or got wrong that you'd like to correct or add?
No, but I'm sure most of your listeners know you, but for those who don't, Hugo has been a long time colleague and friend. I met him on the data science track of like SciPy and PyData, where he was putting together really great tutorials and things like that. So it's just been an interesting decade, like you said, working from tiny NumPy arrays now scaling up to gazillions of parameters with the current AI ecosystem.
It's super exciting. And so that's actually a lovely point to jump off from. Even just thinking about the AI ecosystem and what's changed over the past several years. So let's rewind like 2.5+ years to, I think, January 2023. OpenAI released something called function calling, and everyone else soon followed. But we had that introduced the ability of LLMs to use tools, right? And we got JSON mode and all of those things. So I'd love just your take on the history from like what's happened in the past few years with the agentic space, moving from basic function calling to what we're seeing in the agentic landscape today.
Yeah, and let's actually to frame this, let's rewind a tiny bit more into the models themselves, and we'll move forward. So right around actually a decade ago, which seems to be a good mark, uh, before you and I worked on LLMs, LLMs were really good at like completing text. You would have what we now call pre-trained LLMs. But if you look at early, like say GPT-2 blog posts, they talk a lot about how the LLM would take a piece of text and it would complete it. Like it finished a sentence, it would finish. Um, if you put in some Shakespeare quote, it would finish it. So let's call those completion LLMs. The next sort of thing that happened was what instruction tuning is it's called. Google released a paper called Flan, and then the most famous one obviously is ChatGPT. These are LLMs that now have the ability to understand and follow instructions, but generally the idea is they can chat. Like ChatGPT, obviously is the famous name, but we have Gemini and many other models as well. These are probably the models that most people use. I'd say probably 99.9% of people use the models in this way. They go to gemini.google.com or they go to a Gemma model. They say, hey, give me a recipe for eggs, and you get recipes back. That's a natural language instruction. But something a lot of us notice at once, even within Google, is you could also put LLMs in this like third mode. And you could say, hey, you have a function that's calculate dates or get weather is a very canonical example. And you just say in some what we now call system instruction, uh, answer to a user is normal if they ask for eggs or things like that. But if they happen to ask about the weather, you can respond in this very particular way. You can create this format and emit that, and that would be a great response. Or you'll say, kind of in the instructions, you can call this function. And so now if you say, hey, what's the weather? the LLM can do something else. Instead of just, hallucinating what the weather is, because LLMs don't have access to the weather by themselves, they could actually produce this string that the inference side or your computer or the serving platform could detect. It could actually go then grab the weather, put it back into the context, and then respond. And that is what we called, what is now called tool calling or function calling. So this is to go into this again. There's sort of three modalities of LLMs: completion mode, chat mode, and now function calling slash tool calling mode. And just one quick thing before I give back to you, Hugo. Tool calling and function calling are used very interchangeably. So you might hear say tool calling or function calling. For the purposes of this podcast, just treat tool calling and function calling to be the same. And agent will mean something else in a second. Another very conflated and overlapping term, but we'll get to agent in a moment. But Hugo, I'll throw it back to you. Hugo, I can't seem to hear you. You might be on mute.
I was. So can you see my screen?
I sure can. That's what I
So
see, the great docs.
yeah, and this is from Gemini, right?
Yes, it
so
is.
this actually talks about how function calling works, and a lot of the time you don't need to do this yourself. I think it's good to do it some of the time, particularly when learning how these things work. But one gotcha is that there are actually two LLM calls, right? You pass the initial prompt, and the LLM will trigger a tool call if internally it seems like that's the correct thing to do. And modern LLMs, that they used to be really bad, and we'll get to this, they used to be kind of bad at figuring out when to call a tool or not. Now they're a lot better, and we can get to the implications of that. And then if there's a tool call, then you'll pass it back, the result of the tool call, into the function. So we see that in this schematic. The other thing that I really like is, and this is an example that we use in the course, and it's the weather API. In fact, if you say, what's the weather in Sydney? And you provide the LLM with a good description for the tool call and telling it that it actually needs latitude and longitude, most LLMs will actually take Sydney and convert it to latitude and longitude under the hood without you asking it to, because it quote unquote knows that's what the API expects.
Yeah. Uh, to summarize that real quick, it is a much more complex set of interactions between the model, the user, and the interaction environment than a simple chat response like, what is the capital of Australia, which is just a single return usually.
Exactly. Cool. So we've got to that point in history. Let's move on. And this is tool calling is not just weather APIs. It's the ability to ping Google Drive or email or Slack or create slide decks and all of these things. Coding.
Coding is a
tools,
tool
right?
now. Now there's Terminal Bench, typing in CLI commands. We have Gemini CLI. There's interacting with a browser. If in the most extreme scenario, you have robotics. So a physical robot is a tool that an LLM in Gemini Robotics can use. So this space has gotten really big, really fast.
So what happened next?
So I think it's basically what you summarized, and actually it's fantastic that we're talking on Gemini 3 day. To the folks out there, Hugo and I have pushed this session a couple times, and we switched it to a podcast because every time I talk to Hugo, it's like there's so much happening so fast that if we do a workshop now, it's going to be out of date. And now with the Gemini 3 launch today, you can see how that is like true. We wouldn't have had the time to put together a workshop given it just released this morning. And that's kind of the answer to your question, Hugo, is that Gemini 1.0 was released when I was on a release. I think it was December 2023, which was just actually just like 2 years ago. Honest, a little less than 2 years ago. And that had basic. I don't actually know if we supported tool calling the API. Like I'm starting to even forget. I think we might have only released tool calling in Gemini 1.5 in February 2024. And so we went from very simple tool calls like get weather, and quickly we've gone to, in 17 months, gone to LLMs that now are just doing fantastic on very complex multi-step, multi-hop type of agentic behavior. So previously, as Hugo was saying, and he showed you the graph, an LLM was good at maybe like those two turns. It'd go one side, it would get the weather, it'd come back, it'd get the natural language, and we were amazed that it was able to do that very well. Now, with Gemini 3.0, if we look at the benchmarks, it can do things where you ask it to code an entire project, and it'll sit there for 6-7 minutes and then complete the answer for you. Something that I just saw on Hacker News, for instance, is somebody said they just tried a Project Euler problem, and Gemini spent 6 minutes and solved it, right? And in that time, it was making multiple tool calls, getting multiple results, fixing multiple errors, rewriting the code like multiple times, and then it finally got to a final answer. So we moved from a very simple, like, one or two turn interaction that happens relatively quickly with some precision to now this scenario where these models are doing self-sufficient behavior over like 5 minutes to solve complex tasks. It's a huge, huge jump. Uh, Maybe the other way I can put this, to put this in time scale, when I started learning Python, it took me like a year to get the basics down.
Mm.
And it took like another 4 or 5 just to get good at coding up a solid like open source project. And that was me as a human learning. Now Gemini went from creating a basic function 18 months ago to like probably writing entire libraries that Hugo and I wrote overnight without our intervention. Like some of the simpler stuff you and I used to write it in our open source like Bayesian days.
Absolutely.
It's just moving so fast. Go ahead.
Yeah, and I'll actually link to this. I did another podcast I do, High Signal, with Lance Martin last week from Langchain, and he used to work on self-driving at Uber actually, and from the work he does at Langchain, he just has so much insight into how people are building today. And he mentioned two examples. One is Manus, where because of the hyper speed in model improvement, they've essentially ripped out their product 5 times this year and rebuilt it. Particularly what we're now calling an agent harness, which is essentially all the tool calls and all the things that help something be an LLM be agentic, and also Claude Code. Part of their product is model, another part is the harness around it, and as the model improves, they essentially rip out the harness each time as well. So it's actually changed the way we build software, right?
Yeah, I think to that point, it's even internally within Google, like I've rewritten agentic harnesses like 3 times in the last 3 years because Gemini gets so good that I don't need to check for certain things, or I can just defer entirely to the model. But on the other side, we keep doing more and more complex things, so I need to build new harnesses for more complex sets of behaviors than ever before. Like it's basically you're deleting the old part and you're adding the new part, and it's just this shifting window constantly.
Yeah. So we've got some great questions in the chat from Pastor and Julian, both such wonderful contributors and members of the community. They're somewhat related, so I'm going to kind of ask them together, breaking a cardinal sin of podcasting. But Julian wants to know, has Gemini 3 introduced any additional capabilities relative to the diagram where we have, the one we showed, right? And Pastor asks, can we use decision nodes or something similar to change the type of response? Like if it uses a tool, can we try to push it to have a chat response instead? And I've done that using prompting myself for the most part. But yeah, I'm interested in those.
So one is Gemini. If you're using basic tool calling, Gemini 3.0 will just still do it. The API that you saw is totally still legit. You can still use it with your current workflows. It should just work much better with much more complex tools. So that's if you're using the API. But you're also welcome to then build your own agentic system, and we'll talk a bit about more of this on top of the raw API. You don't have to follow that diagram exactly. Like if you're some crazy custom cool project that you want to build on top of Gemini, you can build your own flows and just get a layer down deeper and route things around your own way, make multiple tool calls, like and incorporate images or audio or whatever you want. You have sort of the how do I word this? You have like the standard way of just doing function calls and tool calls, but if you want to build a crazier agent that's totally bespoke, you have all the ability to do that yourself as well using the Gemini API.
Totally. And it's actually something I have started to refer to as, the two cultures of agents in AI, essentially. But the first way to do this is actually using workflows, right? And I'm going to just share my screen and talk it through for people who aren't watching but merely listening, can you now see building effective AI agents?
Yeah, from Anthropic, yeah.
Right. So this is, as you know, the Anthropic post from December last year that I probably talk about a bit too much, but it was so instructive. They tell us about augmenting LLMs to move along the agentic spectrum. So, LLMs are stateless, so introducing read and write for memory, tool calls, retrieval, all incredibly important things. And then starting to do prompt chaining, right? So we can start building workflows together. And there are all types of different workflows we do. One I really like is the evaluator optimizer one. And so this is one way to start building agents. And if you do want more bespoke workflows and to dictate what your LLMs are doing, this is a great way to do it. The other end of the spectrum is really kind of YOLOing it. And it's very difficult to evaluate in a lot of ways, but building kind of large agentic systems with an end user who may be yourself, but like a human in the loop with strong supervision. So I've always told people to start with these types of things, but that's when you're trying to build consistent, reliable software, which we're not always trying to do. For example, I use AI assisted coding daily, a lot of the time, right? And I wouldn't call that consistent or reliable unless there's strong supervision. So when you have high agency, you need strong supervision as well. So I'm interested in your thoughts on kind of these two cultures.
So I think you're correct on this. I think there's some folks, these models can do so much. So there's some folks that just need just reliable, like I need a function, I need it to be called, and like that's all I got. Then yeah, using the basic API is great. But now there's a lot of different ways we can stack these models together. That blog post from Anthropic was one good way of doing it. There's even more when you consider all the ways these LLMs can be used. They could be used synchronously. They could be used asynchronously. Like we could, you and I could vibe code use Gemini two ways. We could vibe code a podcast summarizer, and we'll use it like in a dev agentic workflow and synchronously, and that's one set of one workflow, and then that we could be coding something that takes this podcast and summarizes it and turns it into a newsletter like async, right? And that's another workflow with the same model. So I think to your point, there's like the dead simple case, which is great, the router case, but now there's many other ways to again put these models together in different workflows with different modalities. And also to your point, different risk levels, I have to say. When I'm vibe coding a project at home, I just let the model run for 5 minutes. If I get an output that looks good, I feel great and I'm just good to go. But even in Google, when I'm coding for model building internally, like I need to really, really check the code. I'm less vibe coding. I'm more precisely like instructing my model or my agent. So a lot of what you and I are going to come to is it comes down to your use case and what you need and what you can tolerate. For how you decide to structure and use these models and eval them.
Absolutely. So we'll get to eval in a second, but I love that you mentioned let it go for 5 minutes, and the time is actually a really important consideration here. So I've been using Manus recently for doing research for me. There's actually Manus Mail, so let's say I'm going to do a podcast with someone. I can just CC Manus Mail and it will go off and say, hey, can you research all the topics we've discussed in this email thread? And it will go off and create a comprehensive summary that it would usually take me 3 hours to do with all types of links and references. And it returns that in about 10 minutes, which is great because then I can interact with it, get it to do a bit more back and forth and so on. Whereas if it took several hours, that wouldn't work for me. So when there's high agency, having high supervision, but also on a timescale that matches the workflow what one needs also.
Totally agree.
Before moving on to evaluation, Pastor has another question, which is so good. As models get better and better, will they require fewer tools and orchestration to get the responses we want and good responses?
Oh, I actually have the opposite answer. So one is maybe less orchestration. Well, actually, okay. So there's a couple of factors. I think if you keep the task complexity fixed, they're requiring less orchestration. I actually posted about this in LinkedIn just like 30 minutes ago. There's some prompts with Gemini 3 that I've noticed just take less instructional orchestration than they did before. But as we put them in more and more complex scenarios, sometimes you have more orchestration to match the complexity of your task. This I like food a lot, so I'll give you the dumb example. And I like Hugo, he's Australian, so I'll give you the stupid dumb example. If you're gonna make a chips and Marmite sandwich, there's really not much instruction needed for that thing.
Vegemite. That's worse than my Gemini. My Gemini, Gemma foo.
My cousins are New Zealand from the Kiwis,
Yeah.
so I was switched to Marmite. Yes, Vegemite sandwich. It's not a complex dish, right? So previously, maybe you'd have to be really, really precise to the LLM, like, oh, go grab white bread, go grab, Marmite or Vegemite, depending on which country you're in. You'd have to be really, really, really precise, and you'd have to say put it together. But now you can say, Hugo's Australian, make him a sandwich with the correct one, and it'll just know. You don't have to tell it whether it's Vegemite or Marmite. But now we're taking these models and we're having them do super complex things. So we're having it make like Michelin star meals. And so now you go back to a large prompt because the task complexity is increased. So one, I'd say if you keep task complexity the same, my experience has been you need less instruction. But I've noticed that we just push the models into more complex scenarios. So the instruction complexity stays about the same, but you're getting a more complex task done. The other part of your question was, are more or less tools needed? Actually, I think more tools are better now because now the model is able to differentiate between more tools than ever before. So previously, we really only could put like 1 to 5 tools in context. If you put too many, the model would get confused. It wouldn't be able to do like a wide variety of tasks. But now especially with the Gemini models, you could put like 10 functions in. You could put more than you have been able to with the older models, and it's able to differentiate and do more things. And now you have a more flexible agent that can both get the weather and make you a sandwich, and it's able to do so where previously you'd have to make a weather bot and you'd have to make a sandwich bot, and you'd have to keep the context separated because the model will get confused between the two modalities or the two structured sets.
Totally agree. And to just reiterate, as these models get far better at using the right tool, there are less failure modes in the number of tools we're using currently, so we can increase that. I would also add, it depends on your definition of like what an individual tool is, because if you have a web search tool and a bash tool, you get really far, right? And you could be like, oh, I have a grep tool and another bash tool, but it's all bash essentially, right? So I think it's worth noting that. The other thing, just side note, I know we're all, the space is super obsessed with semantic search, but don't forget lexical search and hybrid search are super important. And in fact, you may notice that coding tools use grep for the most part. It's one of the most important tools that they have in helping you read code. So, Ravin, I am interested now in thinking a bit about evaluation. So, I think I want to get to more complex stuff, but if someone's building an agentic system for the first time, what's like the minimum evaluation setup needed before releasing it to real users?
So I think I'm going to answer your question in 2 different ways. One is if it's the first time you're ever building a system, like an agentic system, I strongly suggest you go back and just do the get weather example yourself, implement it yourself, with an open model, like Gemma, which is my favorite, obviously, and just really understand what's going on under the hood. There's always this concept of like leaky abstractions, I have to say, and LLMs are a bit of a leaky abstraction. Like when they're in really, really polished interfaces, like Gemini app or Mariner or things like that, you're getting this really clean, great polished feel, but you're not seeing the complexity that's under the hood that got that system to that state, and in particular all the roadblocks and the dead ends that we ran into from the modeling side and the product building side that let us get to this like really good product. So if you go down and you build it yourself, you'll understand all the pieces and where they're going. So my first suggestion is start with the fundamentals. Go learn basic tool calling and how LLMs create those generations, particularly using an open model. Even if you're not planning to use an open model, just understand how the flow works.
Now, I will link to a workshop that we did exactly on this in the show notes later on Discord.
Um, you want to do this because then you have a good sense of how to build a product and also your evaluation for your more complex thing. So the second part, Hugo asked is like what should you do before you get to your first user? This is actually the same answer I'm going to have whether you're building an agentic project or a non-agentic product. There's always like a good tension here of you want to get it good enough where your user's going to like get what you're trying to do. Um, but then once you get there, you want to release it, in my opinion, as fast as possible because the way your users use your model is going to be different than the way you think you need to use your models. Because with every product, you're going to have this stage where you're building it yourself. You're thinking this is going to be really neat. People are going to love it. And you're coming with your own view of how you're going to use this product. But also your own biases. Like for instance, I test a lot in English and Gujarati because those are the two languages that I know. But I don't test a lot in like Korean and Japanese because I don't know those languages nearly as well. Um, so I get the basics down with what I know, and then as soon as I get to users, I see all the things that I didn't think of. It's a bit scary, but it helps because then you can iterate on your product faster using a full feedback loop from the user rather than just your own feedback loop.
Absolutely. And what I'm trying to do is bring up just a slide. Whoa, I didn't mean to turn my camera off. I meant to share my screen again. You came and just gave such a wonderful guest talk in our course last week. And there's one slide which is actually very relevant to this part of the conversation. So let me just bring this up.
Mhm.
Can you see? Oh, just a sec.
I cannot see anything at the moment.
Can you see your slide?
Yes. Yeah. This is the talk I gave last week.
Yeah, exactly. So I think this speaks to, you came and talked about products that you've worked on, such as Notebook LM, right? So maybe you can just reorient us to this slide as well.
Yeah, so there's you've come up with a cool product idea. It's all really only in your head. These days, which is really great, you can use Gemini or any coding tool to quickly build this prototype yourself, including the visuals now and Nano Banana. Like you really can build all aspects of a product with AI. Code, visuals, design, website, like the whole deal. Um, but this is before you have your first user. Now, you obviously don't want to release something that's totally broken to users, so you're gonna have your own eval sets. You'll probably start with vibe evals, which is you just making stuff on the spot. But as Hugo had alluded to earlier, you're gonna quickly also want to build an eval harness, um, which is like a structured way to run your evals over and over again. Now, you'll have a structured way to run your evals, but you'll only have prompts from yourself. Like the eval set is really just things that you have thought of, and maybe some close friends or yeah, some close partners. But it's a really small set of like what all possible people could do. But anyhow, you're going to use this eval set to help you refine the product until you get to a point where you think it's good enough and it's reliable for your use case. It could be generating podcasts like Notebook LM audio overviews, which I launched last week or sorry, last year. It could be Mariner, which is browsing through the internet. Or on the Gemma side, it could be answering MMLU questions, whatever it may be. But my suggestion is you want to get to users quicker than you sooner rather than later. The reason is your users themselves are going to teach you so many things about your product that you never could have anticipated. They're going to use it. One is they could try things on the positive side and see use cases that you never thought of that you want to build in immediately. So that's like one great use case. For instance, a Notebook LM audio overview, something we noticed is people really wanted more control over the podcast. The initial product only had like a one-click button, and you would just get what you get. Now people love what you got, but they also wanted some fine tuning and some customizability. And so we learned that because we launched the product. On the negative case, you'll learn that the product isn't as good as you thought it was in other areas. Like again, maybe it keeps hallucinating the difference between Vegemite and Marmite and offending your Australian and Kiwi customers. If you're in the US or Europe or Asia, you probably never think about this, but your Australian and New Zealand users are going to think about it a lot. Now you're going to see these come in, and you can build them into your eval set. You can say like, hey, make me a sandwich, and now if I go into Hugo and I say make make a Marmite sandwich, I know he's going to be frustrated as a user, and it won't match what his experience is. But because you've already built the harness, it's very easy for you to plug in this new data. And because you have users, you have a very fast feedback loop to go from feedback, eval harness, eval set addition, to understanding your product, making the fix, checking it with your harness again, and then deploying it.
Super cool. So I now want to clarify one thing. I take less exception to the Marmite mistake. Now I realize it was Kiwi. It was for some reason when I thought you thought it, when it was, because Marmite's British as well. That was more concerning to me than being mistaken for being a Kiwi for what that's. Don't get me wrong. I love the British, but it's there's so to introduce my next question, I want to actually talk. We mentioned an evaluation harness, so and we've done a workshop on this actually. So maybe first you can just tell us what an evaluation harness is in your words, and then we can get to this.
An evaluation harness is just a repeatable way to understand your eval results. So again, let me stick to a food analogy because I think it's fun, and now I know Hugo won't hate me for saying it. Think about it when you're going to make either a Vegemite or a Marmite sandwich. You've never done this before. You do it the first time. You take a bite and you're like, oh, did I put enough crisps or chips in? Did I get the Vegemite or Marmite ratio right? Is Vegemite or Marmite better? Maybe you're from another country. These are things you just vibe the first time, right? But you'll notice that really great chefs, they take notes, right? They'll say that, oh, today I made a Vegemite sandwich. I put this many chips in, and I tried it, and this was like, it was too big or too bad. That act of writing it down and like structuring it is a harness. It goes from you just taking a bite and sort of vibing it to like now you have some structured criteria. On the computer side and the AI side, why we really care, and on the agent side, is we want to have our computer run the eval for us. So while we could go in and type in something like, hey, agent, build me a Marmite or Vegemite sandwich, and see whether it does it or not, we want to do this automatically moving forward. And there's two reasons for that. One is it saves a lot of time if you automate it. So you're going to be running your evals much more often and getting many more data points. Vibing it takes a lot of time because you're running one by one, and you'll spend the whole day doing it. The second, though, which speaks to Hugo's and I statistician program background, is it makes it rigorous. With vibing, it's honestly really hard to get the same vibes every single time. Like you might have a cold one day if you're eating the sandwich. You might be really full from another meal. Like you as a person change your feel depending on the time of the hour of the day or what you try. But when you have an eval harness, everything is structured. The test running is structured. The inference side is structured. The assessment side is structured, and you're getting repeatable results that really are giving you a strong signal of what's different and what's not.
Great. And so to drill down even deeper, and this is something that we did in the workshop that I'll link to. An eval harness, there are many ways to create it, but one really good way to think about it is it's a .py script that consists of code-based checks and perhaps LLM as judge. Of course, you don't always need judges for a lot of things that you can check with code, and a gold standard data set of what you expect users to put into your system and what you want to get out of the system. Is that how you think about it?
That's exactly what it. To me now, and since we're talking about agentic evaluation, it ends up being a little bit more complex than a .py file, because agents tend to be more complex. But the basic idea is exactly the same. It is a set of like Python files. Yeah.
Yes, exactly, and a gold data set, which is perhaps constantly evolving depending on what users are doing. So the reason I brought up this wonderful technical report by Chroma, collaborating with Weights and Biases, it's around generative benchmarking, and what they do is essentially they give a protocol for generating, synthetically generating a gold standard data set for information retrieval and search systems. Okay, so I'll link to it. Kelly has a great video in it as well, 12-minute video on YouTube, and they have all the notebooks, so you can do this yourself. So this is for retrieval, right, and search. You may call it RAG. Of course, RAG is such an amorphous term. I think search and retrieval is probably better here. So I'll link to that. But that's how people think about it for search, and they do some wonderful work in aligning one of their judges based on Shreya Shankar's work on eval gen. I think it is. So this is how, like, current state of the art for doing it in search. I'm now wondering, and you've already led us here, but how do we start thinking about how to build out evals for agents?
So this is there's going to be multiple levels to it, like you said. One is if we go back to the chart that you just showed earlier, agentic flows are just more inherently complex than the simple single prompt, single generation flow. So if you take I'm gonna keep using the same example now that we're stuck on it, is like tell me the recipe for a Marmite sandwich or a Vegemite sandwich. The model just has to respond to you, and you just eval that one text generation. It's actually quite straightforward. But in an agentic flow, it needs to make a tool call, and then it needs to read the response of that tool call, and then it needs to provide a natural language response in the simplest flow. So you're evaling two things. That's already twice as complex as the simple case. So that's just the most basic function calling case. And so you start there. You're gonna have to eval, does it make the function call correct? And then you're gonna have to eval whether the final response is also quite good.
And
if we
just quickly, that mimics
yeah.
what we do in search and retrieval, right? Of course, you want end-to-end evals, but a lot of the time you want to look at retrieval quality. And look, we know how to do that from recommended systems and from classic search. So classically, recall first, re-rank, precision at K, something like that, and then more sophisticated metrics. But making sure your retrieval's right, and then making sure your generation's right.
That's exactly right. It's when you start building. If we shift and broaden terminology a little bit, there's LLM systems or AI systems. Search and retrieval would be another one of these things. It's another component that's added on to an LLM, and of course you want to eval both pieces independently, but you want to eval them together. Going back to the Marmite example, until I beat this with a dead horse, you eval the bread separately from the Vegemite or Marmite, and you decide how to put these things together. This inherently makes it more complex than just evaling one model by itself. For AI agents in particular, I think another thing you should eval is it with different numbers of functions, different complexity of functions. Like just as an API user, some libraries are really easy to use. Like I'll pick pandas. Pandas plotting is like a really straightforward API to use, and you can generate your plots. And then a crazy hard API to use is the D3JS API. There's a lot going on. You have to build a lot of components yourself. These are like the extreme ends of visualization. If you're trying to build an agent that automatically, let's say, visualizes spreadsheets, which you totally can do, you're gonna have to eval. Can it use the pandas API effectively? Can it use the D3JS AI effectively? And make a decision between those two extremes. It's another area of eval to think about with agents. And then if we move on to the most complex form of agents, which is agents that are not just making function calls, but making like multi-turn, multi-hop decisions, like let's say Mariner has, where it takes in multiple screenshots of or multiple web pages and views the browser and then makes actions. You're then gonna have to eval over multiple steps. And over noisy images, over things that happen on the open web that don't happen in a very clean sort of LLM environment. So you really just have to understand your system well enough to know where the friction points or challenges could come in and really build out evals around the areas that are most likely to cause a bad user experience or derail your system. And I know that's a very, very general answer. But it's hard because there's so many different ways. It's like, how do you eval any recipe that's ever been generated? Well, they're also different. There's not just one single eval set for every type of like dining experience, even let's say. And it's the same thing now with these agentic systems. There's just so many different ways you can deploy them into so many different users. The evals will be quite different.
Absolutely. And I love that you mentioned depending on what's happening in your system, because the question arises, there are so many tool calls. Which ones should I focus on writing evals for, and all of these types of things? And the answer to that, of course, is, as a lot of people are saying now, look at your data. And, the data scientist curiosity and mindset is essential here. If you see that there's a particular tool call that doesn't work as often as you'd like, that's something to write an eval for. So making sure you're aware of what happens in your system. And in fact, we mentioned doing vibes first. vibes can get you kind of far. I'll link to this, but in Anthropic's more recent blog post on building their multi-agent research system, they actually, when they looked at some initial traces, they saw that the sub-agents were often summarizing content from SEO, like SEO gamed blog posts that had crappy content. And they only saw that because humans looked at it and then recognized how to fix that. So they could immediately solve that. The other thing that I found really interesting is that it looks like LLMs and agents are getting better. And I didn't think we'd get here this soon, but getting better at healing their own prompts if they're given failure modes as well. So we have some form of recursion happening here.
Yes, I would say on that point, Gemini 3, I think, is been really good about understanding where things are going wrong and then self-correcting. You have to remember, sometimes it's not the agents, it's not the LM's fault that things fail, because sometimes your environment fails. The API response doesn't have the right token, you hit a rate limit, the API fails entirely, and the model can correct for these now, when previously it would just sort of bail out. So to that point, you should eval not only the successful golden path, but also the paths where things tend to go wrong. But luckily, as the earlier question alluded to, now these days the LM can handle these things on its own. You don't need to retry from the programmatic side, which is something I had to do much more often just a year ago. I'd have to detect in Python whether there was an API failure and then reprompt the LM in a different way. These days, I'm finding myself just throwing the response to the LM and just letting it figure it out, and ripping out all of my logic for failure detection.
So you also mentioned that, with the complexity we have now in multi-hop, agentic systems, that type of stuff, that perhaps, just writing a Python file isn't all you want. So maybe you can tell us a bit more about how you think about kind of how to build these systems in infrastructure as well.
So the dumbest way I can put it is that there's so many nuances that a single Python file won't capture it as much anymore. So usually I'll have a Python file that's like just test the function calling ability. Then maybe I'll have another Python file that checks whether the natural language response is good, and then another one for checking failure cases in the simplest type of thing. But if you get to super complex scenarios, then sometimes there's things like dynamic evals, where the eval can adapt as the LM is moving on, like a system that the LLM makes a call and you have another LLM potentially mock a response or things like that. Like, there's so much room now not to just have a static set of prompts and responses that you grade against, but much more nuanced dynamical systems, especially to test edge cases and things like that, that I would encourage you to try these out. Like, really think about your evals as an edge. I think Hamel says it a lot, or a couple of people say this is quite often, that your evals themselves could be a competitive advantage or something that increases your velocity, and you can come up with deeper eval systems than single POI files these days.
Totally agree with
the
that.
Last one, real quick one on that
go
one. The last one on agent system is like, I've noticed more and more people doing this. It's just Docker, like they spin up Docker containers to just do a bunch of eval stuff. That's more than a .py file, right? There's a whole environment for an agent to go try a bunch of stuff out in. The whole Docker container becomes the environment. They tear down the Docker container at the end, after it's made a bunch of file systems changes or whatnot. But that's like a deeper eval than just a Python file.
Yep. And I do totally, I think evals will be a huge part of products moats, particularly in how they allow you to do really rapid product iteration and spin things up and spin things down as they work and don't work. Of course, data is a huge moat as well, and will continue to be. I'm just interested, as we've hinted at, systems like Gemini and Mariner support just more integrated tool use at larger scale. And I'm wondering what developers should learn from these kinds of systems when designing their own evals.
One is, I think, just look to what other folks are doing is good inspiration, or like as what's possible, because you can see something like Mariner where you're getting a bunch of UI understanding and multi-hop, and you can think about what is it that I'm seeing with my users that could use this kind of behavior, right? Google is, in our own way, we're like proving to you that Gemini is super capable by putting it in all these products that you're able to use for yourself. But you also can take the power of Gemini or Gemma and put it into your own things that Google doesn't know about. So that's one. The second is then you can play a game where you like try and think about how would you have evolved the system. You can use like a Mariner or anti-gravity or whatever, and think about just like what is it that I would have evolved if I was to make the system myself, and then build that eval for yourself as well. So with Mariner, for instance, since I worked on that more, you can see that it takes multiple turns and it can do multiple actions before it comes back to the user and asks potentially for guidance or approval or help or things like that. Um, and so you can build that into your test harness for the product you're building is like a multi-hop eval or a test to see the limits of multi-hop in your particular system. And then of course the rest of the discussion just goes to what Hugo and I have already said is then you're going to want to that eval then becomes your like secret tool. Something you don't necessarily publish to users, but something you can use to iterate quickly on whatever it is that you're trying to build with these LLM systems.
So I'm wondering if you can just speak to, I mean, collab agents are really interesting now. And then there's a product called Stitch that I don't think a lot of people know about. So maybe you can just tell us about what's happening in this space.
Yeah, so I'll say these are products that I haven't worked on directly at Google, so I'm going to give you my secondhand experience from my colleagues. But these are some of Google's coding platforms and coding tools. So um, Colab Agent is integrated directly into Colab. You can use it. You can use it now, and it essentially is like your pair programmer or software engineering, data science, or programming buddy that will help create plots and pandas code or whatever you need to do in a Colab. So a good example now is I used to have to write the pandas code by hand for plotting. These days, I just click generate and I say I need a bar plot with these colors, and I just let Colab do that. Stitch is more involved. It goes and codes for you, I believe. And so these are LLMs that are being used in Colab is a little bit more synchronous. Stitch is more, I believe, async, where it's going to go out and do things for you while you're not at your computer. Like a totally different user experience than sitting down and watching in an LLM run on your own. And,
So something we've talked about in passing, but haven't indexed on explicitly. Um, More and more agents are working with images and files and speech and other multimodal inputs. So how should we think about designing agentic systems and evaluating them when we're entering a multimodal space?
yeah, so I just to that earlier point, it's you just take the text complexity and you just increase it a bit more. So as you talked about Stitch, Stitch is like a UI design agent, for instance, for web applications and things like that. And so it's a mix of like providing code outputs and image outputs. In one sense, everything stays the same. You now just input instead of inputting maybe instructions in text, like look at this file and edit the Python code. You say, look at this image. And I guess with Nano Banana, you can actually do this. You can say, look at this image and remove all the ducks, right? Like this is it. We can build an AI agent that removes all like the ducks from an image. Your inputs now wouldn't just be text; it'd be an eval set of images, as well. Um, and so same as text though, you would have an eval set of images. You would run them through the API. You would get back a set of edited images, and you would eval whether you are happy with the quality of what was outputted or not. Now, there's a couple of additional pieces of complexity in that, like working with audio and text takes more, sorry, audio and images takes more time. It's not as easy just to grep through it, but the fundamentals stay about the same. Um, but as we've talked about before, now having an eval harness is a really good idea because you're not just dealing with text in, text out, you're dealing with many more moving pieces. And it becomes much more easier to handle all of this when you have computer assistance through an eval harness.
Super cool. Something we hinted at earlier, particularly when talking about Anthropic's research agent and what Manus does.
Mm-hmm.
There are a whole bunch of modern agent architectures that use orchestrators to spin up sub agents and move context in between them. So I'm wondering how you think about these systems, and I think the jury's out on whether that will be the future. But what challenges arise both in design and evaluation for these types of systems?
Yeah, and so admittedly, and to be upfront as well, I have not worked on one of these systems myself yet, which compresses context or orchestrates with multiple subagents just in this way. So I'm gonna speculate though, with you how some of these systems may be designed. I mean, one is when I think about evals, it's just like I think at two levels is like what is the end-to-end product experience supposed to look at? And in this case, we could surmise one big model passes off tasks to a bunch of smaller models, and then you eventually get a thing done. So on the level of the product, I'm like, does it just get the thing done better than a single model? Like, does it do it, and does it do it better than an alternative architecture? Um, but on a detailed level, I think about all the different pieces that need to happen for this to occur. So I can think about like, well, maybe one subagent needs to take it. Maybe one of the things is it needs to compress the context. Does it do that well? That's just the one piece of this like orchestrator system. So I would break that down into a sub eval. And so I'd have this mix of like evals that are like end-to-end sort of product evals, but also like a lot of smaller evals that test like individual parts of the system out. Now the conceptually they should connect and roll up, but that's part of the eval design mentality, thinking at the different levels of which this system works, and then ensuring I have evals that check at every particular level.
Mm, makes a lot of sense. And yeah, I do think the context issue is so interesting now because, of course, we have really large context windows, but we see there's context rot as well, right? So if you utilize even, sub amounts of the available context, we see degradation in retrieval, among other things. So something that people have been doing with these systems, these architectures that use orchestrators to spin up sub agents, is having an orchestrator agent essentially offload the context to a sub agent that works with it, compresses it, isolates things, summarizes it, and passes back up the relevant stuff there. And I am interested. Also, of course, don't want to know any secret sauce about the things you work on, but just how you think about context engineering in your work and managing context for agentic systems.
Well, so to this point, right, you're like earlier LLMs would have these context route. Like I mean, first time earlier LLMs would just have context limits that were much smaller. Going back again, like the first model I released, I think had a context window of like 4K, which is which is laughable these days, right? So you'd have to do a lot of this context management manually yourself, outside filtering, all this sort of stuff. Their first Gemma models had a context window, I think, of 8K. So again, you'd have to do all these context management things in Python. But as the ecosystem moves forward, now we have context windows that are like 32K, 128K, a million or more. And so all this code we had that would manage context, we could just start ripping out. Now, to your point, you could still have context segregation in that context itself. And so I would say earlier versions of Gemini weren't as good at keeping context over the million tokens as Gemini 3. So one way on the going back to the original part of this podcast is like with Gemini 3 coming out, since we have eval harnesses at Google for our internal stuff, we just run those eval harnesses again and see whether if you just took out all this stuff for certain systems, does it just work, right? And you can, with an eval harness as a user, you could do the same thing. These layers of context engineering and previous context issues just fall away with these newer and better models. That's the hand wavy answer of like, as models get better, you need less and less stuff. But it is very much true. But to go back to your question, when we were launching Gemini 1.5, for instance, with the million context window at the time, I would just run a lot of evals with this thing called needle in a haystack. You would put in a random fact in the middle, and you just see where in the context does the model remember things and where does it seem to fail more often. And then you could use that to structure your prompts. You'd maybe put the important details at the top or the bottom, depending on how this particular model is doing. But this, going back to my previous answer, this was me understanding that, hey, we're going to do this really long context retrieval task that users want. We don't want users to have to worry about where to put in the context. So let me run a bunch of evals at the context, just on the context window, to like understand how it works really well with this model. And then I will structure the system so it puts the important details in the right place in the context. The user doesn't have to have to worry about it. Like this is the end-to-end level of thinking that helps with these really complex agentic AI systems for you to really hone in on what is holding back your product and fix that area. And then also repeatedly do that. So as new models come back, you can build in that new model, reduce the complexity of your product, which helps you ship faster and keep up with all the amazing advancements that are going on. It's really just like this symphony of things that are happening all at once and all together.
Yeah, and I do the points well taken that evaluation is just incredibly important here to guide what you do and what you're working on. I do think context right does continue to like needle in a haystack does seem like a vanity metric in so many ways because a lot of the time the benchmarks and I haven't looked at the Gemini 1.5 paper in a while. But you know, once again, the Chroma team's report on context rot shows that if you just put a couple of distractors close to it, like needle and haystack performance degrades completely with higher context.
So this is you have to build your own. Like this is where I really think folks should build their own. And this is another pitch to build your own evals, right? Like nobody, not even Google knows what you're going to do with our models. And so in our case, for instance, we could tightly control the context, and so we didn't have to worry about context segregation. But you could end up with a different application where this is an issue. Like you could have multiple users putting in multiple things, like a meeting summarizer or something, and you're having all this distracting stuff, and the model performs much more poorly than, let's say, the Notebook LM case, which is you're highly curating super high signal sources that are then getting put into Gemini's context.
So I am interested in from an external take. It seems as though frontier closed models from the labs just are far better at tool calling and function calling and building agentic systems than open weight models. Now, so I'm wondering, firstly, if that is a characterization you would agree with, and if so, when building agents on top of local or open weight models like Gemma, what changes?
I would say it's maybe this isn't too controversial. It's not too spicy of a take, but um, models that are hosted on production grade infrastructure tend to be the smoothest, easiest user experience. Remember, when you're using models, there's two things that are happening. You have a set of weights that have been trained, but you also have them deployed on top of a system that is serving that model to you. Now, that system could either be something like Google's providing to you in terms of Gemini and in our API, or it could be your own MacBook that's running it. And so an example that Hugo showed earlier is that with like tool calling, we've built a lot of things in the API to make it a much smoother experience for you, both on the model side and the API side. And on the open weight side, you need to go do some of these things yourself. So generally, yes, building agents on top of these APIs will tend to give you very high performing models on very, very high performing infrastructure, and your life is a lot better. If you're going to implement them yourself, especially open weight side, you will need to get down like a LangChain or an Ollama, and you'll work through the model's capabilities and the inference framework's capabilities yourself. Or if you're really in the weeds, you'll develop your own inference framework with its own agentic inference layer and do it yourself. I see very few people do this, but it's like something that the most hardcore people can do. You sometimes see this with like some of the coding companies. I think I'm forgetting which one off the top of my head, but in some of these IDE editors or who is it? Cursor, for instance, is a really good example of this. Cursor is building a very deeply integrated inference stack with their with some of their VS Code type of stuff.
Yeah.
But on the part, one catch I'll give to the open models is you can fine tune them, and so it's very well understood that Gemini, for instance, is a very general model. It does a lot of things quite well, but it is a general model. Even within the Gemini or the Google ecosystem, there was a Gemma variant called C2S, for instance, which could predict cancer. And I hesitate to call it an agent since the word is overloaded, but it could do this thing where it understood and could understood like cancer markers quite well. And it was able now to then predict cancer markers better than Gemini could, but it was very, very specifically fine-tuned to do cancer markers. Now, it wouldn't be able to do literally anything else. It couldn't answer questions about Australia. It probably can't answer questions about what to cook for eggs or anything about your dog, but it is very, very good at this one specialized task. If you're going to build something that is hyper specialized, fine tuning for that case can yield you great improvements, which is really only something you can do with an open model.
Totally. And I'll link to a wonderful podcast that we did and a workshop we ran on Tiny Gemma when you released it. 270 million people, not 270 billion.
Billion.
And
Yeah.
I hadn't planned I hadn't planned asking this, but could you just like give us a quick rundown? I just love it so much of the Gemma family from 270 million and up.
Yeah, so at Google, we recognize that there's like a huge need and capabilities and usefulness of very large models, like Gemini that are just generally great at a lot of things and really large, really good at pushing the frontier of what AI can do. But equally, there is folks that need models that run on device on what we say is a single node, like an H100 or below. That's really something you can take, put it on your system, fine tune it, make it your own, to serve all the other things. And so in the Gemma family, we have 27B model is our largest model, but it fits on a single H100 or A100. But we go down to 12B, 4B, 1B, and the smallest now is 270M. So this is something that could run on your phone quite reliably and quite easily. So to answer this like agents question again, like if you need your agent to work somewhere without internet, where like you're off the grid, uh, then you're gonna have to use a Gemma model. Like you can't use Gemini, and that's the easiest eval. Is like it literally just will not run. This isn't an agent, but it's a fun example. Is we have Dolphin Gemma. It's a fine-tuned version of Gemma that runs uh, literally underwater with scuba divers, researchers who are like next to dolphins. Like so, you're in an ocean. And even if you had Starlink, I presume it wouldn't even go into the water. So you have to use a local model to talk to these dolphins in the ocean. We have a Gemma model that's specialized for that. And so similarly with 270M, we made the small model that's super easily fine-tunable, which you could take and train on your own functions and make it a really great like small function calling model. Now, admittedly, if you ran an eval, could this thing code an entire Python code base? It would miserably fail. Like just being very blunt, I don't even have to run the eval. It's not going to replace your coding agent or Gemini CLI. But if you need really, really great like 1 to 5 function calls, for example, you can easily train a Gemma 270M to be really good at that one task, and it'll just be great at that one task.
Super cool. And actually, one example we went through in the workshop, and this is a huge use case, and you know, a not insignificant part of the economy is on-device gaming worlds and having NPCs able to generate language, and of course fine-tuning language models around what you want NPCs in gaming worlds to talk like is incredibly useful.
Exactly.
I am interested in just hearing your thoughts. We're going to have to wrap up in a minute, but I'm on your thoughts about what you're excited about in the agentic and evaluation space more generally in the coming months and maybe even year.
So there's two aspects which we talked about, and I'm equally excited about both. One is as the top line models just get better and better and better. Gemini 3 thankfully released today just before this podcast, and I'll leave it up to you folks to take it and see how much better it is than Gemini 2.5. I believe you will be pleasantly surprised, but this is literally the best an AI model has ever been able to do in history ever. Like it's really, really cool to see the frontier move forward, and especially so much at such regular paces. So the frontier side is very interesting to me, but there's also this idea, which is called like the Pareto frontier, that the small models are also getting better. Now they're not becoming better than the maximum limit, but for their size, they're getting much, much better as well. And so Gemma 270M, Gemma 4B are really good examples for that. Are they the best models that have ever been created? At this point, no. Gemma 270M is not the best model that's ever been created. But is it the best model for its size and its efficiency and its usability for fine-tuning? Like, yes, I think so. And it is something now that opens up use cases, so many use cases for folks that had like on-device or low inference cost or very specific needs to push the frontier in those specific areas. And actually, I'm very excited to see all of that, which is how people take take models of their own and push these not sub frontiers in that they're smaller, but like different frontiers than where the large models are going. And that is quite exciting to me. So I'm also excited to see users take the Gemma models and build their own evals, see that there's areas that they could improve their performance on, and then fine tune these models to really excel for their particular use cases.
Incredibly cool. And I'm actually excited to jump in and use Gemma 3 ASAP for many reasons, but the next week of our course is actually on function calling and building agents, and I've been using Gemma 2.5 in a lot of it. So after this live stream, I'm actually going to go and see how much I can change to Gemma 3 and see what the results are. So I'll report back, man.
Awesome.
Thanks everyone for watching, and thank you, Ravin, for your time and wisdom and just all the great chats we have. So really appreciate it, man.
Of course. All right. Thank you, folks.
Yeah. See you all soon.